Right, frequency and pulse width, very small right now. Right, I actually added some comments on my previous video about the actual, well, my cyclic RMS at the moment is around 8.8 volts, which really isn't that efficient. I'm actually charging some supercapacitors at the moment, which I have got LEDs on, and I got sick of looking at my bright LEDs because they were giving me problems with my eyes. So I thought, well, I'm going to give up with the bright LEDs because it's just causing me a lot of struggling with seeing white spots everywhere, and it's hard for me to focus on what I'm doing. So I decided to charge up these supercapacitors with little yellow LEDs which balance the cells out, and it's just making it life a bit easier for me. And also I can measure the voltage as the supercapacitors are charging up, which is kind of quite slow. The reason it's very slow is because my RMS, my cyclic RMS is only about 8.8 volts. So I'm basically charging these supercapacitors. It slows right down once you get past 8.8 volts cyclic RMS, or about 8 volts cyclic RMS. It slows right down because those are the spikes, right? So I'm basically charging up the remainder of the supercapacitor with the spikes, which is basically the pulse width of 60 microseconds. So yeah, I'm going to be at it forever, and obviously it's not going to provide me with a substantial amount of power. Now the reason for this is because I'm driving it with a power input of about 16 volts, right? And that 16 volt translates, when it's been converted into AC, converts into about 44 volts peak to peak, which is what I showed you on this scope. If you skip back and look at that again, you'll see the peak to peak on the input on the yellow is about 44 volts. Now the reason for that is because I haven't got my primary coils, my actuation coils, I haven't got them right yet. They aren't right, which means that they're actually consuming too much power. So I'm going to be winding some more coils for my actuation, and instead of using 34 SWG wire at about 300 turns, I'm going to be winding them with something like 36 SWG, possibly around 1,000 turns. We'll have to work that out as I go along, but that should enable me to still use a higher voltage, but it will mean I can widen out my pulse width. My cyclic RMS, whatever, will improve if I widen my pulse width from whatever it was at. I think it's around 60 microseconds or something. So I should be able to increase my pulse width by, say, 120 or even a millisecond or something like that, whatever. Anyway, the more I can widen my pulse width, the more efficient my cyclic RMS will become, and I'll be able to get a better power factor on the output, and hopefully keep the current consumption down. So anyway, the supercapacitors are charging up very slowly, and we hope to see that speed up substantially when I get these coils wound more appropriately. And another thing I need to do, I was talking about in a previous video, if you go back and look at it, about my two little guys on the seesaw thing, the difference, there's a magnet arrays. These are the magnet arrays in here, in each one, on each side. Now there's actually quite a big air gap between the magnets. The magnets themselves are actually 5mm wide, so I'm going to make some more of these, which are going to be basically 5mm wide. That's to close the gap between the two little guys I was talking about in the description when I was describing the situation. So these are the two little guys that basically on each side either represent north, south, or north, south, depending on which way they're pulling, you see. And the actuation coil is doing the pushing and the pulling, right? So anyway, I need to bring those two together closer. So if I make this thinner and this one thinner, so it's the same width as the 5mm magnets, then the actual centre of balance will be a lot closer together. And also by improving that offset balance, we should need less power to shift the flux. The reason being is I haven't actually got a large one I can show you with, but let's just get the small one. But at the moment we have, say, on the inside we have north, south, north, south. These magnets are pulling against each other, turning themselves off. Now we need to bring the balance of these closer together to the one on the other side. So we'll get two of these. I'll show you with the small ones because it's just easier. If we get two of these now, because these two are very close together, effectively, there's only about a few millimeters difference. So we need to get the offset balance between those and we need to get these about the same on both sides, so that there's about the same gap between the magnets and between these magnets on this side, these magnets on this side. So we need to have an equilibrium there, so that when we're switching, it's more balanced between the two, and we can, when these are actuated across, then our outputs will on each side will actually be switched as well. So anyway, that's all I've got to say at the moment. So yeah, I've got some more 3D printing to do. I might even make my actuation coils a bit thinner. I don't know yet. We'll see. I'll do that simply by thickening the bobbin thicknesses on the ends or something. I don't know yet. We'll see. But yeah, I don't think it needs to be that much thinner. I think the main difference that needs to be taken into account really is the offsets between the magnets, so the magnets can be switched through more easily. You know, the gaps. I don't know how to put it really. Anyway, that's it for now.